Hello, everyone. Welcome back to those of you that were at some of our previous London Games Network events, and welcome to all the new people that have joined as well. We're really excited again to be able to host one of these. As we said, we're planning every quarter to host a London Games Network event, joined by some amazing speakers again today, as we always are. So we'll have Ola Corson kick us off. Now, I don't know if any of you have played Raid Shadow Legends, but I'm almost certain that you all would have heard of this game at least. We've got a lot of fans in our studio. As a lot of you all know, Plarium is a sister company. We're really good friends, so we're really excited. So thank you, Ola, for joining us. We can't wait to hear your talk. Afterwards, we'll have Ruth, who's going to be talking about harnessing marketing insight. Ruth is a senior CRM manager here. So thank you so much for offering your evening to speak. Can't wait to hear your talk. And finally, apparently we're going to have Nicholas Baremio. I'm sure he's here somewhere. He knows he's on last, so maybe he's coming a little bit later. But he's going to be talking about game AI techniques. Now, just a few bits about this before we get going. Firstly, please do use the chat section. I can see somebody already is, which is great. So this is where you can kind of chat about the general talks and what's happening. We'd love to have all of you on camera and all of you speaking, but obviously that's not going to be possible. You know, the last time there was over 100 of us, it'd probably get a bit crazy, but please do use the chat panel. If you would like to ask questions, I'm double checking. Yes, there is a Q&A panel. Please use it. So during the presentation, ask any questions you have. After each presentation, I'll then ask the presenter each of those questions, so we will get those answered for you. We have tried to leave in time for questions. Obviously, previously, we didn't have enough time for that, so we've tried to leave enough time for all of your questions. I can see Nicholas has joined us now, which is great. And finally, last thing is, you know, we've obviously done a bit of rehearsal. We've tried out the tech, but sometimes it's tech and it might play up. So just please bear with us. If anything goes wrong, we'll try our best to keep everything running smoothly. And yeah, follow us on social, follow the event on social, and please use the hashtag. I'm still trying to find something that's a bit better than hashtag London Games Network. I know it's a bit wordy, but that's what we're stuck with at the moment. So please use that. I would love to get your thoughts on the event and to get involved there. But without further ado, I would like to hand over to Ola. Now, for her presentation, there are going to be two videos. Any of you that have used Zoom will know that videos don't work so well over Zoom. They don't play very well. So what we're going to do is I'm going to pop the two links to the videos in the chat. And then when which is the chat section, not the question section. When we get to those points, Ola will point out and say, please play video 1, please play video 2. That way you can play at home. It'll work really smoothly and everything should work that way. I'm going to get out of the way. You'll catch Ruth later. Nicholas is here now. He'll be here later, but Ola will pass over to you. And yeah, can't wait to hear your talk. So
hi everyone, and give me a minute, please. I'll share my screen now. Yeah, all right. I appreciate you joining today, and here's some information about me. I'm Ola Corson, and I work in Plarium for 10+ years. I'm team lead of production animation team now, and I work in the best team in the world now. We are Plarium Global, and Plarium Games has over 20 games from RPGs to casual adventures, and publish on mobile, social, and PC. We've got studios in USA, Israel, Ukraine, and Russia. You probably know us best from Raid Shadow Legends, Vikings Wars of Clans, and Lost Island Blast Adventure. In 2017, we were acquired by Aristocrat, so now I'll introduce some of our games. There are Nords, Total Domination, Stormfall, Pirates, Soldiers Incorporated, and maybe the best you know, Raid Shadow Legends. So today we'll talk about creating convincing animations for fantasy creatures. Maybe you've heard some information about Raid Shadow Legends before, but today we'll talk about animation count here. We have about 470 plus unique animations, about 450 plus champions, about 400 plus custom skins, 100 plus characters skills, and about 30 killer bosses, about 18 weapon types, something about 16 plus factions, and 13 or 12 rig types. So now go please to the link 1 and watch the video. I will give 2 minutes for this.
If you like, actually, I will also try and share it from my screen. I can. I don't know if it'll work though. It might just be better to let people try it from their homes. I think last time we tried it was a bit, so I leave that to you.
We can try, but I don't know how it would be better.
Probably not. Okay, we'll leave. I'll let all of you. So I've put the first link in the chat if you want to watch that video.
Yeah, you can just watch. Okay, let's see what do we have. 400 characters with 7 animators. Nothing is impossible, you just need a plan. This was the first thought when I talked to our art director and he showed me these numbers. So it sounded a little bit crazy, but it was very excited to create this plan, create this system to make it work. So what did we need to do? 400 characters, 10 animations for each. Would be something like 4,500 animation only for the battle scene. And this is not including unique bosses, UI animation, or complicated character skills. And it sounded quite big numbers for mobile games and for our team. So if we'll count like one animation takes 5 days, including some reference finding and maybe some testing, then we'd need around 7 years. And what did we have? Shock, yeah. But really we had 7 animators and 3 years. And this is not including other tasks, like as example, skin for 450 characters. Somehow we did it, and it was kind of magic. But if really not, it wasn't a magic, it was hard work. So here's what we had, the team. And yeah, this is the most important part. And I work in a really very good team and I appreciate working with them. And I've been working with them for 5 years. And this was that was the best years in this company, I think. We have everyone in the right place and no one is irreplaceable. So we are trying to be maximum flexible as it possible. We have one main rigger and one person who can take the task. We have 2 skinners and all other team who can make skin customizations too. And of course, all of us are good animators to take the tasks. So the first idea is sharing skills. It gives us more flexibility in task distribution. We are trying to share skills after some courses or when you just get some new information that helps your work, or just help each other, try to help each other as much as it's possible. Just give some feedback to each other or some different things. So our assets. A unique sharing system, a guide describing skills, weapon types, racial characteristics, etc. The ability to test our animations in Unity 3D by our team, and complex rigs. That gives us the main thing is the ability to add new characters quickly and easy. And this is a very important thing if you have a collectible RPG. Because when you have some updates and you should do it quite quickly, and you should have the ability to add some new bosses or new characters, or just some new races quickly and easy if you need so. But if you need to do it with better quality or some unique skills or some unique bosses, you can do it slower. So we have this ability to do it different ways, and this is very important for such kind of project. What's next? Dynamic character with rig reuse. So here you can see the rig of one of the first our rigs and our first characters. It was a dog rig, and at first we tried to combine all that we needed in this rig. And you can see how our first character for this rig looked like. Here it is. And we tried to imagine how would our character for this rig will look like in 2 years or in 3 years or just in future. So here you can see how it looks now. And it's a little different. So it was a little hard to understand this difference and to make the complete animation for this first character, which will look the same on this nowadays like character. So this is how it looks for both characters. This is one animation. Yeah, it has some small problems, but in general it looks good. And if you can imagine, we did this animation for this dog, and now it works on such dragon like you see on the right side. But to make it work easier, you need working guides. And this is very important thing for us. When something goes wrong with rig or geometry, or maybe when 3D artist didn't fit the geometry to the rig, we can have such problems like you see here. So we needed some guides for other teams to understand what do we need, what technical problems could we have, or some things like this. So you need a guide for sharing all information about animation rigs, etc. Working guides help other teams stay on the same page. And here you can see how we use our skin in manual. It helps all people who work with skin or with characters to understand the main problems with it, to understand the main idea of this, and some other things that can be useful for other teams. And we have the same manuals for all teams who works with animations or with something close to it. So you'll increase your chances to get what you're looking for if you follow these guides and instructions. So to resume, we have collectible RPG and lots of characters, and the plan here is really needed. And here's the plan. Make guides for complicated processes. Try to make guides for every process that should be clearer for everyone. And it helps to be on the same page for all teams. It helps to understand how all teams work and how they communicate with each other. Know your product and know your character. You should know your product, you should play your game, you should understand how it works, and all stuff like this. And you should know your character. You are not just animator that animates one character. You are making one piece of the real big game, and you are a small piece of the really big process. So try to know all things that you need to make your job good. Check out all windows where players can see your character. We have a battle view, we have a hero scene and other windows where the player can see our character. The camera could be different, the environment could be different, the lighting could be different. And we should test all animations in all these windows, just to understand what could be the problems here. Make complex rigs and custom skins. Try to think about the future. Try to understand what could be the characters in future. And try to make custom skins. Don't automatize all the process. Just because the quality of the custom skins would be much better than something automated. We tried different ways to do it, but this is the best way. Just make custom skins and check them in all points. And test your character wherever you need. We are trying to test our character in Unity 3D, and we are trying to learn this program to do it well, and to test in Maya 3D, of course, too, before your work goes to QA teams. Just because when you create animation, no one can see some small things better than you. No one can understand how this animation should be, should look like, and you would know it better and you can check it better than anyone. So test your character, test your animations. And have an option to add characters easily and quickly. This is important for every game and every product, I think. And think about all options what you have. Try to have not one option, but some of them to be more flexible in this situation. Now you can make screens if you need. Yeah, and what else do we need? Let's see. We need skills. Skills that you need to be a good animator. Let's think about it. It could be a knowledge of the principle of motion, and this is popular, right? This could be a knowledge of anatomy and something like rigging skills, but you have to know some extra skills to become the best. It could be something like academical drawing would help you to understand the anatomy of characters and some stuff like this. It could be programming. It could help you to test your animations in some programs like Unity 3D. I'm not talking that animator should be a programmer, no, but some things can help you a lot in your working process. Scripting. I'll show you later, but this knowledge can help you to make some tools for your team or for yourself, and no one could know better what do you need and how can it work. And acting. Sometimes it could be funny, but in general it helps a lot to feel the character, to understand the movement, to check the idea, to check the movement. Is it really looks good or not? How comfortable is to make this movement and other things. And don't forget to have fun. While you have to create animation, this is quite serious and routine job sometimes, and sometimes you just need to relax a little and have fun. And don't forget to save such small ideas, then it could be helpful to create some creative things. Yeah, like this. Is that enough? Maybe they had 5 years, but we had 3. And what else could help? A unique sharing system. I will talk a little bit about it. Here you can see 4 characters, different, and 1 animation. This is quite simple example, but you can see it clearly here. You can combine these animations like our technical art team does. You could have some creative skills for the characters if you can reuse animations between races or like between different characters, and of course you can save the time, a lot of time. Rigs and tools. What else could help you to do your best? We use Gear rig as a basement. We create some simple things in rig with Gear, and after that the other parts of the rig are handmade. And we use animation picker to control them all. To have some custom controls for all rigs, and this is quite comfortable to do with this tool. We have something about 13 rigs divided by anatomical features, design, skills, etc. Here you can see examples of some of them, but we add some new rigs when we need to add some new bosses with unique anatomies, with unique features, or new races of characters. But we are trying to make them as full as possible, just to reuse as much animations as we can. But if something can go wrong, it will go wrong. And of course, we can have some mistakes here. We can have some bugs in skin customization, or we can have some problems with the animation reuse, or we can have incorrect rig applied to the character. But we are trying to test all things like this and to find all these mistakes. So we needed a tool to make fixes quickly, and we made this tool. We called this tool Fit to Pose. Our rigger made it, and this is a script that can help you to make such things. Here you can see that if you need to make some fixes to skin customizing and check it on the character, you can do it quickly here with one button push, and you can not apply them if you see that it works not good. And it helps a lot when we test our characters, when we make some small fixes. Also, we needed to do a lot of testing. We have hundreds of characters, and sometimes we have one animation for them all. And somehow we need to test this animation for all of these hundreds of characters. And it could be quite different and long testing. So we needed a tool to make it easier to run tests. And we made Proxy Manager for us, for our team, to check out all animations on all needed characters. So here you can see that you have rig, and you can choose the character you needed easily, just to choose the number of the character here, and to check your animations on different characters easily. So it would look like this, and you can check small details of your animation that are different in both or 50 or some count of characters. And almost the half of our characters are fantastical creatures. So we need to work with references for fantastical creatures, quite usual. And let's talk about this. Where can we find a dwarf, as example? You can try the Iron Hills northeast of Erebor. But if not, you can just become a dwarf. We are trying to make all movements by ourselves. We are trying to feel the character and to feel the movement, to understand how it works, to understand what is the characteristics of this character, and is this movement goes well, does it looks well. And sometimes it helps a lot just to understand this movement. If you understand this movement, you can create animation. It's just the process, yeah. Or you can become a powerful magician if you need, of course. Or even a fire golem. And don't forget to be creative here. You don't need a studio to make it. You don't need some special things. You just need to be creative. You need to have fun. You need to enjoy the process. Or just relax and go to watch movies about dragons. All your players know dragons from movies, and this is quite important to make your animation the common thing for player. So if all players know how the dragons looks like, how it moves in general, you should be on the same page with this. Or become one, like you see here. Such small movements can help you to feel the character. So to work with creature references, you'll need to find the right type of references or a part of it. You don't need to find something straight that you need. You need to find some small parts that can help you to make movement, to feel the character, to make some details or some things like this. Get into the creature's shoes. Try to feel what is your character like, how your character can move, or maybe it's heavy, or maybe it's fat, or maybe some other things. You need to feel this. Study the characteristics of your character. Try to find some information if you need it. Try to find some information about the animal that looks like this creature. This could be nature programs or some videos or some movies or even some texts about this creature. Make the player believe the impossible. Try to make your player believe that this could happen in real life. Try to make the physics work accurate and right, like it should. Even if it's something like fantastical, but the physics and anatomy features should look like real. And not forget the details. Details are very important here, and when your animation is ready and it looks good in general, the timing and everything looks good, you should add small details, and you can see them in some small references, maybe even of some lizards if you create a dragon. How their eyes opens, how their mouth works, how their legs move. So small things that can make your animation more realistic. And use your imagination. Try to be creative in all steps of your work. If you need, you can take the spring. And the most important thing, steady acting. It will help a lot. So we know how to animate creatures, but is that enough to make it work good in the game? Maybe, but the other teams will find and kill you. So you need to think about it. Think about anatomic capabilities in the game and to compare it with in-game skills, to understand how your character will work together with skills and how your animations would work together with skills and in-game processes with some effects that would create your other teams or something like this. Here you can see our boss, Black Widow, and some skills of this boss. Don't forget that your animation is a part of this process. This is not just animation for something that you will give someone and forget. Try to see all complex of this situation. Try to understand that the skills are important here, and you should speak all the time. You should communicate to other teams to understand how it should work, to understand all small details of this complex. So to make our animations work right, we need to find out what skills your character has. Be careful with this. Try to understand everything and be sure that you understood it right. Brainstorm how to animate those skills. What parts of animation can be needed? How it would look like with effects? How it would compare with anatomic capabilities or something like this. Compare those ideas with the capabilities of the character's rig and anatomy. Check the main poses in the scene or some environmental details. Try to see your character in the environment that it will be placed in. Try to check the main poses of the animation in the environment to see everything together, to get the whole picture. And finally, love your work and love your product. And now you can watch second video. I'm not sure that it would be here, but please check out our site, Instagram and YouTube channel to find more information. Check out for our articles that we are writing. We are trying to get all information and to make it useful for you. And thank you. Take the road.
Thank you so much. I really enjoyed that. Like I said in the office when we were talking before, we've got a lot of Raid fans, and I'm sure there are a lot of Raid fans in the audience as well. It's such a, I really love all the characters. They're so diverse, and it must be such a challenge for you as well to have to animate all these different creatures, different sizes, different characters. But it's really interesting to hear your take. So thank you so much. And the audience have asked some questions. So if it's okay, I'll ask those to you now. Also starting with Antonio, who works here at Product Madness. He's asked, how did you organize the documentation and how do you collect your work to quickly see and share it?
We use different things to do it, even presentations for some teams, but in general, I'm trying to make some presentations with pictures, not with text, because no one wants to read text. And even if they should. So we're trying to make it useful, we're trying to make it funny or some way that people would like to see it and it could help. So we can make 1 or 2 presentations for our 3D teams, for our concept artist teams, and some other teams that need to know some information. We can help, we can do some presentations that will show some problems, and we are showing the animations, how they work, how you can see these small problems, how you can solve them, what do we need to know to do this, and it helps if you do it step by step all the time.
Great, thank you. And he's also asked, how did it change your work when you transitioned into working from home?
Oh, I can say that it changed our work a lot. At first, we were a little sad because our team communicates all the time in the office, and it was very hard to be far away from each other, but we try to communicate as much as possible with our team and between teams. Today we have a birthday of one of the team member, and we gave him an awesome present, and we are trying to make communication warm and trying to make some calls, to make some chats, extra chats and extra chats to communicate as much as it's possible.
Yeah, I imagine a lot of people are getting used to Zoom, you know, like this presentation now with everything that's happened. Another question is, how do you tell testers what animations and characters changed? Will they go through all combinations?
This is a quite complicated thing, but we did some small things to do it clear. We are trying to add some videos and pictures to the tasks to make all people understand what should be changed or what is the idea of these fixes. We found like small points where we can push these videos or small things, but the main idea still is that we need to test our animations by ourselves and to make fixes by ourselves.
Great. Next one is, I can answer this. Can you share the presentation? I believe we'll be sharing that afterwards. You can share the presentation.
I'm sure that we'll do it.
Yeah, that's great. If you could send to me, yeah, we'll send a message to everyone after this event, so we will get that to you. Thank you, Anonymous. And then the last one is from Brendan, and I was interested in this one as well, actually. Do you use motion capture for in-game animations?
We tried, but no, we don't use it. In general, we have to do a lot of work, and when we tried to use motion capture, it was too long for us because you need to have actors, professional actors. You need to make a lot of stuff to make it real, and after that, you need to make your keys clean and make all technical things like this, and it could last forever. Like, no, we don't use it, but we could use it for some small things when we needed something, but we're trying to use references of our acting, and it helps almost like motion capture because you see this movement, and sometimes we can just make small parts of references just frame by frame, so it helps a lot.
Great, it's interesting because obviously you had the slide with was it someone in your studio kind of practicing the moves as a reference, or it looked good fun anyway. But that's all the questions we have. So thank you so much for your time. I really enjoyed your presentation. Thank you for joining us. It was really great to have you with us. And yeah, we'll get the presentation to you all afterwards. And just want to say, yeah, thank you so much. I really enjoyed that. That was really interesting. And yeah, like I said, lots of fans of Raid in the office, so I'm sure they really enjoyed it too.
Yeah, thank you so much. I appreciate this.
Great, thank you. And yeah, next up, if she's there, we have Ruth. Ruth, are you ready?
I am.
Right, cool. Do you want to share your, here you are. So Ruth is a senior CRM manager here at Product Madness. I'm very excited for this talk. How are you feeling? Ready for it?
I am just hoping technology holds out. So that's what I'm hoping for.
No, I'm sure it'll be good. Well, without further ado, I'll get out of your way and I'll let you start the next talk. Thanks a lot.
Thank you. Okay. Can you just let me know, Jake, if you can see everything okay?
Yep, all looks good to me. Can hear you, can see you.
Thank you very much. Okay, so hi, my name is Ruth. I am the Senior Marketing Manager at Product Madness on an app called Heart of Vegas. So the deck that I will be presenting today is entitled 2020 Vision, and it is going to go through how you can harness your marketing insight. Some of this, for those that are in marketing already, will be a recap on best practices. However, there are some interesting case studies included, which will really showcase what we are doing here. So, contents of the presentation, I'll be going through how we approach testing, how we sustain the hashtag win when we find winning variants, how we use customer surveys to improve our insights into the events, and how we decide when a trend becomes a permanent or semi-permanent feature, And then I'll be doing a quick summary of all that we have learned and hopefully send you on your way to creating some of the best in-class tests we know for marketing. So testing. So I'm sure we are all very aware of SMART objectives. These are usually things we put together for our personal development and growth. However, thinking of objectives with these 5 pillars really helps us define our goals and our KPIs for our marketing tests. So S being making it specific, M being measurable, A attainable, R relevant, and T, which is very important, making them time-based. So put all those together and you should be able to concretely have a goal or KPI for your marketing activity. Here is an example of the marketing process that we are executing right now in our marketing teams. It is a fairly simple 6-step approach, with the number 1 being the said KPIs and objectives, and works its way through all the way to analysis and revision. So step 1, we've said KPIs and objectives, which is the SMART. I've also put there EMR, which stands for engagement, monetization, or retention. So you may want to look at your objective in one of those 3 marketing pillars. Step 2 is where we undertake our planning phase, which can be as long or as short as needed. For larger, long-term projects, the planning stage can actually be quite a long process, with the remaining 5 being quite short. So here's where we get the specialist even input. So that can be from data science, it could be from operations, it could be looking at the competitors, all of that, and where you get buy-in. So buy-in can be as small as support for your project, or could be as large as actually getting monetary buy-in to what you want to do on the brand. Step 3 is where we configure or think about our math templates. So the segmentation we are going to approach and the rewards we are going to give to our audience. Step 4 is art concept, which comes quite far down in our steps. Now, as a marketing person, we are often tempted to start with the art concept right at the beginning. So think about all the fantastic festive and Christmas and Easter campaigns, but actually we try and now put that in step 4. Reason being is, if you do have a lengthy step 2 for your planning and it is tied down to a date, i.e. Christmas, you could actually overshoot your execution date, and then you have to rework all the assets and concepts from scratch. Step 5 is config and health checks of A/B test and the event itself. And finally is the analysis and next steps. So what I'm going to do in this case study is just give a very quick example of what not to do or what we shouldn't be doing anymore. So the first case study is where we have a very, very loose objective of just improving sales. Now, some of these easy options I'm going to share are not wrong. They are just not the best way to go about things. So an easy option would be to theme it. I've mentioned why this could be a downfall, mainly because you could overshoot timings and then your theme has to be reworked, but also because you end up then putting all your KPIs and all your clever segmentation and squeezing it into a theme or concept, rather than let the theme and the concept really promote and add to your basic mechanic. Another one is just to make it last longer. Why not just run your sales longer? Therefore, you will get longer and better interest in your sale. The issue with this one is the T in the SMART objective, which is making something time-based. If you don't have that certain end goal, so this could just go on forever and ever if you just make it last longer, it means you're not very strict in where you are pinpointing the milestones for success or failure. An easy option is also to just give more value, give the players even more. This again, in theory, would improve an individual sale, but could have a terrible effect on sales in the future. So would they continue to buy or engage in that sale if they have received so much from your initial one? Another one is to send comms and also add in more placements. What this does is generate more interest or impressions of your event or sale. But again, we have that same issue that we might have a lag or after effect after this. So here's how we can really tighten up our approach and make a very specific KPI. So now rather than improving sales, we have the KPI as increasing transaction size, and this is very specific. So where's the opportunity? Well, perhaps we can look at how much players are willing to pay in a sale. So MFPP stands for most frequent price point, and HPP stands for highest price point. So we can look at what they usually pay and then look at what the highest thing they've ever paid in a sale and really see if there's enough stretch there to really get customers to increase their transaction size. How much value are we prepared to give to those players that do stretch? So for players that do stretch their most frequent, how much value are we looking to give them? What does success look like? How will we know that we've achieved our KPI? And what are the benefits to the player? So when you are constructing a new event or campaign or sale, you don't want to just look at how you are going to benefit from this, but how will a player view this event and where do they benefit? For me, I also try to look at competitors or at least things around me as an example of how to do or not to do things. So when looking at sales, I looked at where I frequently purchase and I look at retail therapy. I noticed that when I am buying on the high street or online and there are sales, quite often the sales only apply to those of the medium or high range objects. There are very few circumstances where I see that the brands that I love actually reduce the price of those of the basic or bottom tier items. And I think what this does is for those that are at that base level and just buying the basic items, when you reduce those of the medium and top, it means they're just slightly out of reach. And you have to then make that conscious decision. Are you going to purchase up to get that very, very valuable product? It also means that they do not reduce the value of their base items, which could then really change the economy of their brand or their products. So I thought, how could we use this sort of insight to really take this into the test we want to do on stretching transactions in our sale? So what I thought I would do, this is a very, very basic and initial plan, is to look at a 3 price point sale. So a sale that has 3 entry points. And I decided, right, the first one should be set around what their most frequent purchase price point is. The second one should be looking at a step up from the most frequent price point, but I really want to see if I can have for that third price point, their highest price point. So something they might have purchased a long time ago, and if they're willing to do that again. To answer the question of what do the customers get out of this, I want to be giving them increased value when they do stretch up to the top, but very little if they maintain their usual paying behavior. And these are just a quick snapshot of some of the results at different bands of customer. So if we just pay attention to all the graphs that are on the right-hand side, on all the pie charts, the red highlighted segments are either the highest or the bridge amount, and the gray ones, the dark gray ones, are the ones that they're most frequent at. So if we concentrate on this side of the column, we can see we had a large portion, pretty much a third of people that were willing to stretch to the highest price point. And it is a common theme amongst all the payment brands that we have, payment bands, sorry. So you can see here at this top echelon, we have just over a quarter that are willing to pay at the top amount for that added value. And we see this along all the different sale categories and bands. So just to conclude in terms of setting up the test and how to make it specific, work on a SMART objective and secure primary KPI. Have a hypothesis. Think about the test as much as the event. Ensure your exploration leads to execution. So what I mean by that is when you set up the test, make sure that the answers you get from there are actionable in your next iteration. So now that I have a test and I have results and I can see there are a lot of people that are willing to pay for that top end product with that extra value, how do I optimize or keep or maintain that hashtag win? So here we are very happy with our results, but how do we keep that same momentum? How do we keep that same vibe moving forward into the next iterations. Here's our results so far. So from that first test, we see a 5% increase in revenue. We also, from that test, see about 80% increase in the average transaction, but a natural decrease in the amount of transactions. So this tells us we had far less payments on that sale, but that very generous 80% increase on average transaction led to a 5% increase in total revenue. So have we succeeded in increasing the average transaction? Definitely. And we have definitely had an effect on the increase with our increase of total revenue, albeit with a deficit with our amount of transactions. How can we optimize? So looking back over the segments, I could see that we had missed something. There's an opportunity here for us. So with those in the group most frequent 25 to 40, we see a very even split of all three price points. Now, in the old sales before we did our test, the ranges were $29.99 to $99.99, and then we increased the bottom range to $39.99, but our top range only went to $89.99. This means we have a potential value by increasing this top element to get more revenue. So what we did is a 50-50 further test, where one kept the $39 to $89.99 band, and the other one had the top price at $99.99. Another gap in our test that we thought we could optimize on was for the most frequent price point, 15 to 25. Now here you can see the vast majority were spending on the lowest price point, which is their most frequent, and another large majority were on this second. Very few were willing to stretch to $59.99, which was the highest stretch. So we decided to split these out into two other segments. So from these 15 to 25 most frequent, for those less than 50 at the highest price point, we then split that into those less than 20 and those 20 to 50, just to give a slight bridging gap. The people that were, didn't have a high stretch, they were less than 20, reducing their top amount. So going from $19.99 and $15.99, reducing that for under 20 highest price point to $17 and $24.99. For those that were 20 to 50, we changed their range from $19.99 to $59.99, and we just kept it there for those that seemingly had more ability to reach that top price point of $59.99. So just to summarize, 50-50 split on the 25 to 40 segment with an increased top price point stretch, and then we added a lower level of split for the $5 to $15 stretch, as it appeared that the top point was far too aggressive for them. So can lightning strike twice? So what you will need to do when you run your test, as we have just seen there as an example, is check for blind spots and edge cases. Make sure there isn't some really simple low-hanging fruit that you can just take advantage of rather than running a whole new iteration of your test. Where can you make concessions and where can you optimize? All questions that should be answered once you've found a winning variant, but you want to do better. So those two first, chapters of the deck were looking at A/B tests and how in real case studies we were able to optimize and bring results. This next part is looking at how we can gain insights from customer surveys. So there's gaining insights from A/B testing, extremely scientific, I'm sure, but there's also looking at surveys and how our customers view our offering. So is there value in feedback? Why do we care about customers' opinions? Well, at Product Madness and at Heart of Vegas, we are very much involved in looking at how players view our brand, what we give out, our games, all aspects of the app. Why? Because there are a lot of apps that have social games on there. However, we want to be best in class. And the only way we're going to be best in class is if we're looking at our customers' opinions and making sure we're reactive to them. However, creating a meaningful survey can be quite difficult. Often, I'm sure if you've run surveys before, you found you have lots of answers, but not a lot of actions. So you need to make sure you understand what you want to learn from the survey. So ask the right questions. Who do you want the survey to go to? So look at your audience. Is the subject matter fit for the audience you're sending it to? Do you want to reward participation? Rewarding participation, in my experience, means you get a lot more volume, but then sometimes customers are rushing through results to make sure they can collect their reward. Add reference points. If you're talking about events in the past, don't expect your customers to remember them. Show them images, show them videos, make sure they understand what the questions are referring to. To get scientific, make sure you take all your results and analyze them, including who they came from in terms of your audience. And avoid free type. Try to narrow down how your customers answer your questions. Free type is a way, I think, to add confusion to a lot of surveys. Although it does give you raw examples, it does also mean it's quite hard to quantify at the end and prove and make actions from that. So here's just some examples of how I have styled surveys. So as you can see on the left-hand side is an example of how the event looked in-app when it was live. And then here's the corresponding survey art. You can see we've taken the sort of main elements and the iconography from the event and put it into the survey. So hopefully those people taking the survey have remembered what the event is and they would have taken part in the original event itself. Here we have a survey that was comprised of very many events, so very much a generic marketing survey. But again, we've tried to include the titles, as you can see, of each of the events or the icons there and put them into the survey art here. In terms of the two surveys I've just shown you, the first one was on a sale, and I won't go through all the questions and the results, but here's just an example of how I have taken two distinct results in the test and used them to change or affect my V2 of that event. So one was, an answer was, it was clear how to take part in the sale. So 90% of people responded that. And about 55% of respondents said they were going to take part in the next Dragon Treasure sale. So what did I do with that information? So we'll see. So here is the initial event design. So let's just tackle this first point, which says 55% of people want to take part in the next Dragon Treasure sale. So first of all, we started increasing the frequency of the event. So rather than making it a kind of quarterly execution, we ramped that up to be something that is monthly. And we also have increased communications to engaged audiences. So if you do take part in the event, we then send you follow-up communications days in advance, letting you know when the next iteration of the Dragon sales will be happening. Point number two, it was clear that how to take part in the event. So 9% of people said that. Before this survey, we did start a task of redesigning the whole format, as we were not sure people understood how to take this vertical, I guess, growth to the best offers at the top. But once we got this answer back from our customer survey, we actually ditched all our attempts to restyle and stuck with our original design. The next survey we have here is the Have Your Say survey, which goes over all of our marketing events and tries to get a general feel from players how they engage with and react to our events. So the two highlights I have taken from here, that the all games events, so events where they could qualify on any game inside the app, were better received, and that users wanted to see bigger rewards. So here's the original campaign here, or one of them, which is the Lucky Scratchers on all games. So the first point, all games are their favorite kind of event. So what we did with that is just to freshen up the assets and run more all games events. I mean, that is quite a simple reaction to that. The next point is users wanted to see bigger rewards. So 84% said that, and that's not a surprising answer to get from players. So we have updated our Scratchers event. We now have given them opportunity to win more rewards, albeit behind a virtual paywall, but if they do pay, they can double the rewards on their Scratchers. So you can see that the original event is up to 250 million coins, but if they pay and unlock the deluxe Scratchers, they will actually be playing for awards up to 500 million. What we also did, if you can see the difference between the art there, is that rather than just making it a general event on the app, we have added an opt-in option here. So players can either say they're not interested, or actually they can opt in. What this does mean is it removes all passive generation of scratch cards. So if you're not interested, we don't pay out the scratch cards money. We only give scratch cards to those that opt in. It means that we saw an actual reduction in coins, 39% reduction. Let me just go back in coins. Let's go back there. 39% reduction in coins that were given out. And that was simply because we weeded out all the people that were not interested in the event. And we also saw an increase in click rates. As you can see, only 76% clicked on this informational, which went up to almost 94%, because they had to make this conscious decision of whether they wanted to take part or not. So now we actually have reduced coins by 40%. We are now at liberty to give more coins in the next iteration of this event, and therefore answering more back to their response of having more rewards inside an event. So trends to features. This element of the presentation is more about the questions we need to ask when we have winning variants. So when does a test variant become the norm? So at what point when you have a winning variant in a test, do you say, actually, this is just something we're going to run now indefinitely? When do you turn temporary to permanent? So these events that you put on maybe every month or sporadically depending on the calendar event, so Halloween or Christmas, when do you decide that they need to be on a schedule because they work so well? So every Friday, every Tuesday, for example. And when does a marketing event become a product feature? At what point do you say, this is so good, it needs to be fixed inside the app as something players can take part of, a part of our general offering of enjoying the app? And at what point do you say, rather than having this as a BAU campaign or a business as usual activity, perhaps we automate this. Perhaps it just goes out all the time when we want to players when they hit certain segmentation. So just in conclusion. So part of our 2020 vision for marketing, we need to be focused. We need to define a specific SMART objective and KPI. We need to wear blinkers. We need to only consider actions that will directly feed into the KPI that you have already created for your test. Test your vision. Create a test to prove your hypothesis. So not only do we need a KPI, we need to try and think about how we are going to achieve that KPI and let the test prove that hypothesis or feeling about what's going to happen. Regular check-ins. Create milestones during your test to confirm the progress is going in the right direction. Check point of views. How do your customers view or experience your actions? What is the reception? Sometimes looking at the revenue uplift is not just the only way you can attain that something is successful. Did customers enjoy it? Did they feel like they were being benefited by taking part in this event? And look for opportunities. Where can you transfer success? Can this be a part of your regular product and marketing offering? Thank you very much. That is it.
Thank you, Ruth. That was really interesting, and you're a great presenter as well. Really enjoyed that a lot. So thank you so much, and thank you for sharing. So everyone, now's a good chance to pop some questions in the Q&A. I had a question for you, and I'm sorry if it's, I'm obviously not as knowledgeable in this field, but I've worked at a few other studios before, and when I joined Product Madness, I was always impressed with the level of kind of professionalism and kind of talent in marketing. I think we do such a good job with that. Obviously I'm biased, but if you are a game studio that hadn't maybe put any focus into any of their marketing when it comes to kind of the player base, how would you say they should begin with that? I know it's a really wide question, but maybe like a tip to how to get started, because it all looks so kind of overwhelming.
Yeah.
How do you think would be kind of the best first steps, really?
Well, I would say I think the marketing processes still apply for those that have zero marketing and those that have overwhelming amounts of marketing. it is best to find what the need is first. So are you trying to improve the revenue? Are you trying to drive more people to your site? Are you trying to get them to play as many different games as possible in the app? And I think once you kind of confirm that particular objective, then you start working around looking at, if you're a player that doesn't have any marketing or an app doesn't have any marketing, looking at the tools you have available. I think sometimes there are answers to objectives, but they are not readily available to do. You don't have the budget for it, for example, you don't have the resources, you don't have the art team. So what can you do with what you have? But as long as you have an objective and a clear time frame to test and optimize, then I think you're on the right track.
Great, thank you. I think that's really good advice, especially mentioning budgets, because obviously, yeah, like you said, every studio has different budgets, from sort of, you know, 2-person indie studios right through to the big ones. So no, thank you so much. I really enjoyed that. Any other questions for Ruth? Please still put them through, because we can put them to Ruth later on. But no, thank you so much. And now we have our final talk. So Nicholas, are you there?
Yes.
Cool, right, we'll get you on board. Thank you very much, Ruth. Really enjoyed that. So, Nicholas, you will be our final speaker, senior Unity developer here at Product Madness, and you joined, I believe, a few months back.
Yeah, in March. Yes, March.
Great. So, yeah, you joined as we all left the office, obviously. But thank you so much. So, yeah, I'm going to hand over to Nicholas now. I'll get out your way. And any questions, please put them in the Q&A panel as well. Thank you.
Great. Thank you, Sheikh. Well, hello, everybody. My name is Nicolás Borromeo. I'm from Buenos Aires, Argentina, and as Sheikh said, I'm a Unity senior developer here in Product Madness. I'm also a Unity certified instructor programmer teaching in behalf of Unity for several companies. And I started using Unity in 2009, if I remember properly, in Unity 2.6, teaching it since 2012. I wrote a book about Unity, and as you can see, I love Unity and game development. So I hope you enjoy this session as much as I creating it. So what I will be talking about, I will be discussing mainly AI for video games, not AI in general, but the specific techniques used for video games and the differences against the regular AI, the famous AI that nowadays is like neural networks or image recognition. So I will be discussing the common techniques for game AI, from the very, very basics, like saying finite state machines, all the way to more advanced techniques like GOAP or tactical pathfinding. So the idea is that I will be discussing like a very high overview of them. So I won't be discussing the implementation details. So if you are not a programmer, you will be also enjoy this session. So it's targeted for a broad audience. So let's have a brief discussion between the differences between regular AI, like the AI that computer science studies, versus the AI from video games. And the big difference is that the regular AIs wants to look for the perfect solution or for the best solution to solve a problem. Whereas the game AI wants a completely different approach. Wants a solution, of course, but wants a fun, believable, and human solution, in a way that the characters this AI are driving are like believable, are fun, and fun to play with or against. So here I have two pictures of two very, very like, descriptive cases about this. In the left image, we have the famous Deep Blue AI beating Kasparov, the greatest chess player in that time. And, you know, I won't play a game that hard in my life. I won't look at that. Deep Blue was seeking like the best possible killer machine against any chess player. And on the other side, I have a screenshot of a game called Devil May Cry, DMC, one of the several occasions. You can tell that the AI here this game has a pretty simple AI, but the main point here is that if you play that game, you will see that the AI is like easy on purpose. In the first enemies of the AI, they like take ages to beat you, so you can basically dodge them and start making infinite combos. So in that case, we have a totally opposite. It's not an AI, an unbeatable AI, but an AI easy to beat on purpose to improve the fun of your game. So that's the main difference, and that's why the techniques between the techniques used to make Deep Blue AI versus any other game are fundamentally different. Maybe some are the same, but slightly adjusted to have control, to the game designer to have control about how he expects our AI to behave. So that's the main difference. Having this into account, let's discuss the different techniques to implement the AI. And before actually discussing them, I want to discuss a general, a very like basic AI architecture that every entity or agent or AI object in your game will have. And every AI is composed in the following 4 parts. You have information sources that are basically every kind of information source the AI have, like sensors, or maybe just having information about the, I don't know, the health or the player it will be fighting against, or the amount of bullets it has. I mean, all kind of information that needs to gather from different sources that will serve to make a decision. And all this information will be stored in a memory, a specific place where we have like the database of knowledge of our AI. And then we will have decision-making systems that will take information from the memory and make a decision. And based on that decision, it will say the actuators to do something. The actuators can be a variety of different systems, like pathfinding systems or walking system, making the AI walk towards a specific place, or shoot, or play an animation. Here is like the actions the AI will be taking. But you can see that all of these are decided based on several other systems that we can say the AI is only these 3 parts, and this is just the actions that the AI will be executing. So every single piece here, every single part of the AI can be implemented in multiple ways, especially the decision-making system, one of the most important ones, can be implemented in several ways. So we will discuss mostly that, but let's start discussing how to implement the memory and the information gathering. That is basically the very, very core or the AI. And this is the simplest part, but one vital part usually is not exclusively implemented like this, but one common way to implement the memory is through a system known as Blackboard. The Blackboard basically is like I said, a knowledge database that is basically separated from the other systems. All the systems will communicate with the Blackboard, but it will be separated from the other systems in a sense that we have loose coupling between the systems. If you are a programmer, you know that loose coupling between systems are crucial. So Blackboard is a way for, as an example, if the sensor of vision sensors, the sensor detected an enemy, it will put the position of the enemy in the Blackboard. So later, when the decision systems executes, it looks in the Blackboard if we have information about the player position. So the sensors and the decision systems are completely separated, and we can exchange them freely because they are, as I said, separated. So again, we will have different sensors like hearing, sniffing, why not, and vision, and other kind of information sources that will be putting information here. And sometimes even actions will put information here. But again, this is a simple concept, but pretty important, because then the rest of the systems will be using this. So this is the middleman between most of the systems. Now, let's start talking about the most basic decision-making system every AI programmer ever programmed. It's like the ABC of AI development. That is the finite state machine. The finite state machine is basically a set of states or actions and transitions between them. What I'm meaning with this? Here we have an example, FSM, where each rectangle is a state. A state is basically a code or an actions that the AI will be executing. So I'm always in one state and only one state. Let's say I'm in roaming. So while the AI is in the roaming state, it will be, well, roaming, just wandering around and like serving the area he's patrolling or whatever you want. So we have fighting against an AI, fleeing from the player or another AI agent, chasing the enemy it will be attacking. So me or whoever is the AI programmer will be thinking about which states our AI will be composed, which are the actions we need the AI to do, and will think in a set of states. Then we will be coding them, of course. But the next important part, aside from states, are the transitions. Remember that we are just in one state at a time. So let's say we are roaming. So if we are roaming, we have a set of conditions that can be met to change the state or transitions. So if we are roaming, in this example, we have two possible escapes from roaming or transitions from roaming. One is enemy within shooting distance. If this condition is met, we will change in roaming. It's like roaming is no longer an useful action, so we will switch into another more useful action, that is fighting. Or if we encounter the enemy, but our health is low, instead we'll be going to flee. So as you can see, the idea is that you will be creating this diagram of transitions between states and diagram the AI in that way. This is, again, the very, very basic AI technique. And to be honest, it will cover 80% of the cases you will be needing, because usually we need simple AIs. The problem with this technique, and the reason why other techniques exist, is that basically it will be a mess if you will need to handle lots of states like this image here. You can see that this image is a mess. You have lots of states and lots of transitions, and adding a new state or detecting a bug here is a hell. Honestly, that's a hell. I've been there and I hated every second in this kind of state machines. And like as a tip, this is actually a state machine, it's an animator state machine. As you can see, the concept of state machine can be used in several other aspects of video game programming other than AI. But let's keep into the AI field. So we can simplify this using other techniques like advanced sub-state machines, but the general idea will be there. As more states you have, the more problematic will be maintaining this AI. But that will be covered 99% of the cases. Let's now talk about another part of the AI system, another common part that is an actuator called pathfinding. Remember that actuators are the part of the AI that actually executes and does something. So let's say the FSM decided that we are in patrolling state and we need to patrol maybe all the way on the other corner of your scene. So you will need to find a way to reach there. If you are in a simple game, maybe just move directly towards the target is okay, but if you have a wall, you will need to avoid it. And if you are maybe in a labyrinth, you will need to find like a more advanced path. So here is where pathfinding kicks in. Pathfinding basically is that, looking a path between 2 points in your scene. A scene can be very complex, can have lots of meshes, vertices, or sprites if it's a 2D game. Analyzing every single face or mesh in the scene is basically it cannot be done in real time. Remember, your game needs to run at least 30 FPS, and this algorithm can be very, very expensive if you're not simplify the scene in any way. So usually we have systems that analyze the scene and generate 2 different outputs. One can be a graph, a network of interconnected nodes. In this case, the nodes are basically positions, possible positions in our scene, and the edges, the connections between the nodes, are basically paths or maybe walkways between the 2 positions. So in this case, we have a simplified version of a scene that have 5, 6 possible positions, and we can move this way. We cannot move between 3 and 5 because there's no way between them. A more advanced version of this is the nav mesh or navigation mesh, that is, in a sense, is the same. It's a network of interconnected nodes, but in this case, a node is not a specific point in the floor, but a full area. In this case, we can see that we have this rectangle here that is a node that is connected with this other polygon here that is another node. So basically, the same algorithms to find paths between the graph will be used here, but with the help of these areas rather than points, that allows you to decide how many agents can be maybe climbing this hill here and not like falling away from the sides of the wallway. So once you basically simplified and represent the walkable areas of your game with this graph or nav mesh, you can start to applying different algorithms like BFS, Dijkstra, A-star, Kruskal, and any other amount of possible algorithms to detect a position between 2 points. Usually, if you're using an engine like Unity or Unreal, they have their own solutions. You won't need to learn them. But in the inside, they will use versions or modified versions of these algorithms. Actually, in this image, you can see Dijkstra running and executing how it works. I won't discuss that in detail because that will be too much technical, but take that into account if you can. So we have decision, we have memory, we have sensors, and we have pathfinding. With that, we have the very, very basic AI you can do. Of course, then you can have other actuators like shooting a bullet or jumping or I don't know, taking a health box, but those are pretty simple and depends a lot of how your game are created. So we have a path, but we need to walk through that path. We can do a path will be basically a set of points we need to reach, but how we reach those points can vary. We can go straight and then turn instantly towards the next waypoint when we reach the first one, but that won't be natural. And remember, the main point of the AI is to create believable characters. So we need to have more like a natural way of moving that. And that is done usually using what is known as steering behaviors. And steering behaviors are basically simple physics-based movements. Simplifications is not a full physics simulation, but it's a physics-based movement to achieve realism. You have a set of steering behaviors that have different goals, like seeking a specific target or fleeing from a specific target, arriving to a specific target, like arriving and then slowly stop. You can have separation, that be separated from other targets, like to not be a crowd all packed in one specific point. Cohesion, to make a set of nearby entities share the same direction. You have a lot of different steering behaviors that you can mix and match to create believable behaviors. Actually, here we have an image of one steering behavior called flocking that is actually composed of three different steering behaviors. If I remember properly, it's separation, cohesion, and alignment, if I remember properly. But basically, there are three different behaviors. One being in charge of being separated of nearby voids. In this case, they are not packed together because that steering behavior makes them separated. We have another that makes the voids try to move towards the epicenter of the crowd, so they can kind of stick together. So one make them packed together and one make them separated. And the other one tries to align the headings all of the voids so they go towards the same direction. Of course, this is mainly based on how birds fly, but this is an example of how you can combine difference. Of course, your AI will need different steering behaviors according to your needs. And actually, this is interesting because these kind of algorithms are not only used in games, but are actually used in movies. And The Lion King used that kind of algorithms to generate this kind of stampede. Not exactly flocking, but several movies use this kind of algorithms to simulate a lot and a crowd of different sets of entities, in this case, these kind of animals. So you can see that it's actually a pretty interesting technique. But again, the idea is that we can use different steering behaviors to make our AI traverse the path calculated by the pathfinding system we mentioned before. Actually, if you use Unity or Unreal to do pathfinding, they use steering behaviors, so our AI moves believable, traversing the path generated. So those are the most common, the most basic AI techniques you need to know to make any AI. With those, you are complete and you can go ahead and make your AI. But remember that we said that basically the state machine has the limitation of having too many states and being a mess when you have too many states. So here is where more advanced techniques kicks in, and one of them is called behavior trees. Behavior trees are a little bit more complex, but manages complexity in a way better situation. In this case, these kinds of squares, or what the states used to be, are basically actions. Each action has different logic. Each node has a different logic. And of course, depending on the node, what they do. So we have nodes that can have childs, and each child will do different stuff. So we have a set of like basic nodes that will be basically the structure for the rest of the nodes to kick in. And in this example, we have one of the most common nodes, that is sequence. This is a tree. As a tree, usually these nodes have children. So sequence, what it does is execute each one of the children. And when a children or any node is executed, it can have a result, or success or failure. Of course, there are most advanced versions, but we will stay with just the simple case, success or failure. So sequence will say success if the execution of all the children is also successful. But that's why it's a sequence. It will basically try to execute everything. And in this case, it's just a way to contain a set of actions that need to be executed in a specific order. So in this example, we have a sequence that first will try to walk to the door. So it will find a door to go, and we will find a path to that door, and then we'll traverse the path to reach the door. Once we say success, then the next node is executed. And in this case, we have another compound node, another node that can have children, because walk to door doesn't need children. But we have another kind of node called selector. Selector is like sequence, will execute its children, but with like an opposite condition. It will execute, it will keep executing the children while they say failure. So basically, we'll try the first. If the first doesn't is not successful, we'll try the second, and then we'll try the third. So let's say we walk through the door, then we try to open the door. If the door can be opened, this will be success. Sector will say, okay, my sphere option says success, so I'm successful, and then we will be executing walk through door and then close door. But let's say the door is closed. So if open door fails, the selector, instead of just quitting here, will try the second option that, again, is another sequence. That in this case will say, okay, I will try to unlock the door. If we can unlock the door, we'll be opening the door and then quitting. So you can see how the sequence selector became to be recursive. They can be called between themselves to start composing more and more complex behaviors. Look how adding just unlocking and opening to the graph is just adding one option more in the selector. And if this fails, for some reason the door cannot be unlocked, maybe we don't have the key, we can smash the door. So this AI will always go through the door. Of course, we can fail the smashing of the door, so no non-possible action, maybe the door is too strong, no possible action will be executed here, the selector will be said false, and this whole sequence fails. And this maybe is a child of a greater tree that handles how the failure of this work. So this is an example actually from an actual game called Project Zomboid. I stole basically this graph from a Gama Sutra article. I strongly recommend to read it. Also, this technique is used in Halo 2, and there's a paper about how they implemented that. This is one paper published in GDC 2005. So I strongly recommend to read that if you are really interested into that. And just for putting an example, here is another example of a behavior tree, but this time this is a screenshot of Unreal Engine. Unreal Engine has a behavior tree system already integrated into it. And has some different concepts, but the idea is the same. You have selector sequences and actions inside. So this is like in a sort of sense, the default, the most standard way to implement AI. If you're not using FSM, if you take any engine, it has maybe first party or a third party implementation of behavior trees, because it's very popular, but also has a con. I mean, this is easy to maintain, this is easy to extend and easy to debug, but sometimes you will need to cancel a sequence and change to another sequence, and that sometimes can prove to be difficult. Maybe you are through the opening door sequence, but another action becomes more important, like defending yourself because an enemy kicks in. And usually that kind of synchronization between different parts of the trees can be difficult to solve, especially if you are doing your own implementation of this. The Unreal Engine has a simple solution, but can be quite challenging to handle those situations, like what we call like persistent nodes, that are nodes that don't execute instantly but take some time. But well, again, I don't want to go too much deep into the actual implementation of them. Just wanted to mention that con that it has. So another decision-making system that is, again, more flexible than any of the others is one called utility AI. Utility AI is based on the utility theory of economics that basically says that we can have a set of actions. Again, remember, the AI needs to do something. We have a set of possible actions. In FSM, each action is a state. In behavior trees, each action is composed in several nodes. And in utility AI, each action is, again, a separated entity, a piece of code somewhere in your script that will be picked based on a set of what is usually called scorers. So in this case, we assign a weight to each possible action the AI can execute, and we basically pick the one with the most weight or score. So basically, we have a set of options, an importance, a weight, a score in each one, and we need to diagram, to program this AI to always make the most relevant action to have more weight in a specific scenario. So to calculate some specific weight or score of some specific action, we have different criteria. In this example, we have, as an example, move to enemy. Move to enemy is scored based on two different scores, like the distance to the enemy, that is linear. See, if we are close, is 0. If we are far, is 100. Gun is not loaded. If we don't have the gun loaded, we have a minus 100. So in this case, if we are far from the enemy and we have the gun loaded, this will have a score of 100. If we are far, but we don't have the gun loaded, we are not going to fight against this, so this will have a 0 score. So let's say we are in that case where we have 100, like we are far from the enemy and we have the gun loaded. So far, move to enemy has a score of 100. So this, for now, is the most important action to take. Then, in that case, same case scenario, we will also evaluate fire at enemy. We are near the enemy, we are at less than 50 units from the enemy. In this case, no. So we'll have 0 score there. Cannot make to cover, so it's like we cannot cover. In this case, let's say, yes, we can cover. So fire an enemy, so yes, we can cover. So again, this will be 0 because this is if we cannot make to cover. And the gun is not loaded. Yes, we have the gun loaded. So move to enemy becomes more relevant than fire an enemy because mainly for this specific case, we are not near enough of the enemy, and we can make to a cover because maybe there's a cover nearby. So this is not applicable. So then we have another example, move to cover. Is not in cover. Currently, we are not in cover. Proximity to cover, let's say we are proximity to cover, 50-50. So look how this became also 100% case. So we are far from the enemy. So move to enemy is 100 score. Move to cover is also possible if we have 100 score. So in this case, we have a tie, but let's say we are a little bit closer than before. This score will immediately decrease and move to cover will again win. And then instead of move to enemy, we will move to cover. And well, you can imagine from now on how is the rest of the states. So basically, it's a very simple way to define because you have a set of actions, a set of criteria for each action, and then the system will automatically pick the most important one. So you forget about behavior trees, you forget about transitions and states. It's plainly simple and can handle lots and lots of cases. Adding a case is just adding a new action with its own scorers, and it's pretty simple, but of course has a con, as every implementation, that is basically hard to balance weights. Introducing a new action will require basically balancing the other scorers of the other actions to like make sure that our new action fits into the proper place. So it has that con, that balancing and find the exact number a scorer needs to have can be challenging. So it's actually useful if you have like a fair amount of states and managing them with an FSM or a behavior tree is complicated. So again, each one of the three systems I said, they are no like mutual exclusive. You will need to pick one based on your scenario. Like as a very, very rough rule of thumb, you can say that maybe less than, I don't know, 7 states, an FSM is just enough. More than 7 states, a BT can be, a behavior tree can be more useful. More than, I don't know, 15 states, an utility AI can become more versatile than like the BT, like the behavior tree. So again, those numbers are pretty rough, but it's for you to understand when to use each one. Again, regarding utility AI, there's a pretty interesting GDC talk called Improving AI Decision Modeling Through Utility Theory. So I recommend see that conference. It will basically clarify a lot of this. So, discussing different, more advanced, like decision-making systems, we have one called, usually, it has different names like solution-based search or GOAP, that is goal-oriented action planning. That is a technique actually being used by the real game. I mean, like Hello, this is other case. FEAR uses it, the original FEAR. I don't know if the sequels, but the original FEAR uses it. And they published a paper in the GDC 2006. So again, I strongly recommend you to read it. It's pretty like easy to digest and pretty interesting. But what GOAP is what GOAP is. Basically, as the name suggests, we generate a set of actions, also known as the plan, to satisfy a goal. A set of action is a set of things we need to execute one next to the other to satisfy a specific goal. So we have actions and we have goals. The actions are usually composed, before actions, we usually define the world in this kind of AI in what we call a state. It don't have nothing to do with the FSM state. It's another concept of state. A state in Go is basically a set of variables that defines the world. In this simple case, we have a simple solution, a simple world when we have a state that defines if we have or not the phone of the pizza place. This is an example to satisfy the need of not being hungry. So in this state, we have the case if we have or not have the phone of the pizza place, or if we have or not have the recipe for cooking our own pie, and if we are hungry or not. So this is the archetype of a state. We can be in yes, yes, no, 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 yes, 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 no, 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 any kind of permutation you can imagine. In this case, our goal is making whatever is our current state to reach the I don't care if I have a phone, I don't care if I have a recipe, my only goal is if we are not hungry. So we can start in any random state, but our goal is this one. So again, this is the goal, our target action. So we have origin and end. To find a plan towards that goal, we have a set of actions. In this case, we have 2 actions that is basically called the pizza guy or basically baking our own pie. So look how every action, the 2 actions have preconditions and postconditions. The preconditions are for calling the pizza guy is that we have the number. It doesn't matter if we have recipe or not. It will be a precondition, a non-exclusive precondition for this. And of course, a precondition for calling the pizza guy is that we have hungry. And the effect this action have on the world is that we have a phone, the state of the recipe keeps as it was, but finally the most important change here is that after this we are not hungry. Of course, this is an oversimplification because after calling we need to wait for the pizza to arrive and then we need to eat it. So, but this is a simple case. And as you can see, the baking pie option is similar. We don't care if we have or not have the phone. We care that we have the recipe and we care that we are hungry. And again, the result is that we are not hungry. So here you need to define the variables that affect your state, your goal and the possible actions to satisfy that goal. Once you define that, an algorithm can be a star or whatever other algorithm pathfinder, because it's funny because you can actually use the same algorithms using in pathfinding to find something here, because it's more or less the same idea. You have an origin and a destination, and you have different paths, different ways to accomplish that. That in this case, the ways to accomplish that are all the permutations of actions in different order. So in this case, we have two possible actions that immediately solve the goal, but maybe we have actions that then allows to execute other actions. Let's say you are creating an AI for an RTS game like Age of Empires, and you have collect wood, collect I don't know, stone, and build barracks as possible actions. In this case, one permutation will be collect wood and then build barracks, because one enables the other. So you can see how it can chain and basically brute force all possible permutations of actions. So in this case, the algorithm in the very, very basic algorithm does that, basically brute force the different possible actions. And once it explores all possible ramifications of the actions, it will stop when we find a possible state that satisfies this goal. So we'll evaluate if the action is possible to execute, and the actions that are possible to execute are executed. If we don't end in the end result, we will again repeat executing all the actions until again we reach the goal. So again, it's a pretty interesting AI, because adding new actions to our AI is just a matter of maybe extending some states to have enough information to execute that action, and basically adding one of these actions to the array of actions our AI can do. So you can make different AIs with different possible actions based, I don't know, maybe in the personality. This example is taken from the FIAR paper, where they show the actions that a regular soldier has, and these are the actions that a mouse has. They have mouse or rats going out there, so they can have their own like goal, and will try to accomplish it with these actions. So it's very versatile, it's pretty interesting. And of course, as usual, as any other implementation, has its own con, that is basically that having too many actions can result in a high time, like a very long time calculations for planning. So the planning can take long. Of course, different algorithms handle that using more greedy approaches to avoid exploring all possible permutations. Like I will explore only the 2 or 3 most important permutations. So you can reduce them, but it can be quite, it can generate quite long paths if you don't manage that some way. So that's another possible decision-making system. Then returning a little bit to the actuator systems and exploring a little bit more the movement system, we saw pathfinding, and we say, okay, the AI wants to go there, but how we determine where the AI must go? Let's say you want to take cover. Of course, you can define a set of cover positions that are ideal, and the AI can go that way. But maybe we want that to be dynamic. I mean, if we know the AI is placed in a specific part of the world, we know which is the optimal cover position. So we can say this is the cover position of this AI, and that's all. But if we make the AI dynamic, walk around, pick a position based on whatever the player gains, maybe we have different ways to arrive a room, so it will be dynamic. So position picking is a technique that is basically the same concept as utility AI, but again used in other place, that is to pick the best possible position based on a set of criteria to weight those positions. And as usual, this is also used in a very famous game, in Killzone, a very PlayStation famous game. And of course, there's also a paper that, as usual, I highly recommend you to read, because it's pretty interesting. But how this works? Basically, we can mix them with the graph of pathfinding, in a way that we define possible positions at nodes in the graph, and then we have the usual connections to do pathfinding. But let's say these nodes are possible positions to take. In this case, we are exemplifying how we can pick the optimal cover position. And again, we have a set of positions. We have a set of obstacles like high walls and low walls. Low walls are basically walls where we can hide and then crawl and then like shoot through them. High walls are basically we cannot shoot through them. And basically the idea is that we can first select nearby waypoints, basically to cut a little bit far waypoints, because the problem is that far waypoints maybe are good cover positions, but reaching them takes too long, and maybe in the first moment we decided to pick a position, it was a good position, but until we reach it, maybe it stopped being a good position. So the idea is that we trim this solution set, these possible options to the nearby ones that are the most useful one, and score them by proximity. The most nearby ones are the most important ones. Then we introduce all set of criteria that depends on what you want to achieve. In this case, we need to find a good cover position, and a good cover position is defined by proximity and also by being inside the preferred fighting range. If we are a sniper, we will be preferring further positions from the enemy, or if we have a rifle, mid distances, if we have a pistol, nearby distances, so we will be giving a score for the ones that are inside our preferred fighting range. Then we will be adding more score to the ones that have direct line of sight towards the enemy, because we actually want to cover but also shoot. So in this case, look how the ones that have direct line of sight towards the target have 20 points in this case, but this one here has 40, because it not only gave us a direct line of sight, but also cover. So it's way better than this one. Then we give a more score to the ones that protect us from secondary targets that we don't want to attack, but can attack us. And finally, we can basically sum up every of these criteria and pick the one with more score. So you can see that in this case, this is the optimal. It protects us from these two guys, it offers us cover, it's nearby, and also have a direct line of sight to the enemy. So we'll be picking the most useful one. Maybe sometimes it's not a good one, but it's the most useful one. And we have other variations of this system. Instead of representing the world in a graph way, you can represent the world in a grid way. And it's basically the same idea. You can point every point in the grid and then sum up the values and find the one with more score. This can be differently calculated, but basically it's the same idea, weighting possible positions. And this same weighting can be used not only to pick a position, but also to calculate a good path towards a destination. Usually the regular pathfinding algorithms find the shortest path towards the target, which usually is what we want. But sometimes we don't want shortest, we want a path that maybe is more safest, or pass nearby, or maybe our friends. Maybe we can have different criteria to to put a score in our paths. So in this case, in this example, the shortest path is this one, and is one that exposes a lot towards a threat. So in this case, what the guys at Killzone, because this is also from Killzone, not only takes into account the distance between each node to calculate the weight of a path, but also calculates the amount of exposure each point in the path has. So in this case, if we put that into the weighting calculations, you will find that the AI will choose to go to maybe a longer path, but less weighty, because it has more nodes outside the viewing range of the threat. So the same idea, the same utility AI, this time applied in the middle of the pathfinding calculations. We are good on time, okay. So then, of course, we can combine techniques. I mean, you will be combining techniques in a sense of techniques for decision-making, techniques for actuators, but maybe you can find combining techniques between different actual same systems. Let's say you can maybe combine utility with utility or finite state machines as nodes in a behavior tree. So instead of you having just sequences and selectors, you can have other composed nodes that can be special ones like utility. In this case, we have a sequence. This sequence, we have some kind of processing of data. Maybe sometimes before actually making a decision, we need to take the data in the memory and maybe filter possible threats from the ones that are in the vision, filter suspects that maybe are something that you see that you need to investigate. And then the sequence will execute other node that in this case can be an utility selector, a special kind of selector that instead of executing the childs looking for one that can be executed, it will pick one child based on utility scoring. So you can see that you can start to mix and match them to your preferred way to handle that. It's not that you use one or another, you combine them as you want. So that was like everything I wanted to say. I have some extra, so if we have some minutes, I have some extra slides. But before actually showing those extra slides, if we have time, I wanted to say that there's much more out there. You have other techniques like genetic algorithms, solutions evaluation, that is a complement of GOAP, restriction-based decisions, cellular automata, neural networks. You have lots and lots of possible different techniques. I explain like the most commonly used in gaming, but you can explore more or your own. And if you want to explore more about game AI programming, you have a site called Game AI Programmers Guild. It's a very good site that has a recompilation of different papers. Then there's the book Game AI Pro, that is a set of collection against of papers published in book format. And as usual, the greatest like source of this kind of information and general game development information is the GDC Vault, that is basically a set of recordings of all the GDCs. Or the GDCs that, if you don't know what the GDC is, Games Developers Conference, the most important gaming developers conference. So here you find lots and lots of information about game development. So we have 5 minutes, so I think it's good to have some Q&A. I know if Sheikh agrees with
that. Yeah, thank you, Nicholas. I really enjoyed that. It was a really great talk. And if anyone's got any questions, please put them in the panel. We haven't had anyone really asking questions today, but yeah, please do use the panel. I had a question though, from watching your talk. So have you found any differences coming over to the UK with our practices here working with Unity? Was it different to what you were used to before? Or is it is it the same everywhere?
No, of course, it has its differences, like mostly the way we work I mean, the general structure of the game is similar to other games I work on, but here we have like a more like strict or more contemplating workflow that prevents us to maybe commit certain mistakes that were easy to make in maybe other companies I work on. So the same code, the same idea, but with a more like contained, I would like to say professional environment.
And what would you say is your favorite game where sort of interesting AI techniques are displayed and shown that kind of really piques your interest?
Game that has a really interesting AI.
Yeah.
I mean, the ones I mentioned, Killzone and Fear, has very interesting AIs, each one on its own, because you can actually see what I said in real time. Like when you play Fear, the AI is not that predictable because has so many resources to kill you, basically. Maybe they can like jump through a glass wall to kill you, and they actually has like kind of group tactics. Ones try to reduce you when the others are flanking you. That are pretty interesting AI. The same is Killzone. It's not that like predictable as other AIs. But of course, that depends on the original intention of the game developer.
I thought it was interesting as well when you talked about sort of the AI around the herds in Lion King, and I thought you were going to talk about the game on the Mega Drive, because that was always one of the hardest games ever, and you always thought it'd be easier. I remember being a kid and you get, oh, it's the Lion King, and then it's really hard. I suppose that wasn't so much the AI, it was just difficult, but that's cool you mentioned that. So yeah, I think that was it for all of the questions. I don't know if there's anything else you mentioned that you wanted to show us.
If we have time, we might have some extra slides I have just in case.
We have, well, I was looking, hang on, where's my clock? We have 4 minutes if you want to share anything else.
There are actually 2 questions I see in the Q&A panel.
Oh yes, we do. There we go. Good spot. So yeah, we have, what do you think about neural network AI?
I actually was the next slide I had just in case.
Cool.
Why I didn't include this into like the general techniques is because it's not really super using games unless it's something experimental. The problem with neural networks is that they are pretty difficult to train and to structure, and basically even if you nail them in the way of having a good training like way to training them, they are pretty unpredictable. You don't have too much control. Is that you train them, and whatever the synapses between the neurons decided to have, they will work most of the times, but maybe some gameplay when you release a game can have super unpredictable behaviors. And if the AI starts to behave erratically, it will be like in a movie, somebody screaming. It will totally distract you and like extract you from believing that it's an actual game. So that's why it's not that much used. It was used in Colin McRae Rally 2 because it's a driving game. So if the AI makes some bad turn or hits the wall, it's not that bad because a human can have that kind of erratic behavior. But if we have the typical agent trying to walk through a wall, it will basically completely be unbelievable. That's why it's not generally used. It's difficult to use, to train, basically.
Awesome. Thank you. Next one is, do you have any advice or tips for debugging plan-based AI systems?
Debugging plan-based, like Go, I think debugging. I mean, yes, I mean, basically checking which are the, yes, it's a difficult question because you can came up with actually absurd plans. I guess you are not referring basically to prevent it like be training forever, looking paths forever, because that can be managed other ways. But debugging it's actually difficult. I mean, you can always like run, like stop the game and run something that prints all the possible plans that are generated. But maybe you can combine to debug if the plans are good enough. You can use this I mentioned before, that is basically a solution evaluation, where you don't only just pick one possible solution, but you also score them. You assign a score to a solution based on the effectivity, because as you execute the states of the plan, as you execute the actions, you have an idea of how the state of the world ends after executing that action. So you can evaluate that to basically like control the possible paths. But as much actions you have, the possible paths are basically exponentially growth, and it's difficult to debug that. So maybe you can add, again, a layer of solution evaluation to check if you basically run your game in some kind of baking mode that executes all possible paths, and you start in different possible situations of the game. Maybe you can remember that in order to execute, let me get back to, in order to execute Go, you have a state. So you can basically generate lots of random states, execute the algorithm offline in the editor, and execute it in different states to see the possible solutions and automatize that testing through evaluation of the possible solutions generated. So if you found that in certain cases it gives a poor solution, means that you need something. Or if it gives no solution at all. That's maybe my advice there.
Great, thank you. I have one more that was in the chat I've just spotted, and that is, which of the algorithms are more demanding in terms of performance?
Each one has its own cost, but I would definitely say Go, because it's easy, again, to have lots of states that maybe one state like allows every other state to execute, or sorry, one action allows every other action to execute. So you start to having lots and lots and lots of possible action, and exploring them can be quite challenging. Again, you can reduce them, explore just some of them, the most important one of them, using this solution scoring that I said before. But basically that can leave you, if you don't explore every possible solution, you can have a very poor solution or no solution at all. So that's like the kind of problems this can have. You can explore lots and lots and lots and hundreds of solutions, and no one will reach the exact goal. So that's you balancing the actions, but this can be one of the more costly ones. Neural networks, once they are like trained, they are usually not quite expensive, depending on the amount of neurons you need. And utility is pretty straightforward. It's just math. It will be okay. Even you can basically parallelize the calculations if you want. Behavior trees, depending of the depth of the tree, so that also depends. And finite state machines, no, is usually pretty cheap.
Awesome. Thank you so much, Nicholas. I really enjoyed that talk. And actually following on from this, we're going to be hosting another Unity developer meetup towards the end of the year. I'm sure you'll be involved as well, Nicholas. We have some of the other Unity team members here as well. So yeah, if you want to see more of what you saw today, please come along to that. I think that pretty much wraps up everything there. Just thank you so much, Nicholas, for your talk. Thank you to Ruth and to Ola as well. And to all of you for joining, giving us time in your evening or in your morning, wherever you are. We will host another event probably towards the end of November. We're looking to do these events every quarter. So yeah, any suggestions, please let us know. I will send the slides over in an email, probably get to you all tomorrow, sort of morning time. And yeah, it's been great to have your company and can't wait for the next event. Thank you, everyone.
Thank you, Sheikh, for inviting us. See you guys.
No problem. See you all soon. Have a good evening.